Hello students, welcome back to a new mathematics program for grade 8. In today's program, we are going to talk about real numbers. But remember students, this is a chapter that you have started in grade 7, where you learned about the different types of numbers, namely even, odd, prime, composite, square and triangular numbers. You also learned about integers, both positive and negative integers. Then you learned about fractions and decimals. So in this video, we're going to talk about real numbers, but we're going to talk about the subchapters called natural numbers, whole numbers, and rational numbers. But before starting this chapter, let's have a look at some examples where real numbers are used in the real life. First, have a look at this picture. These are two banknotes. How will you differentiate between them? Apart from the color and the size, of course, you're going to look at the numbers written on them. The first one is a 1,000 rupee note, whereas the second one is a 25 rupee note, because it's written 1,000 in the first one, whereas 25 in the second one. This is a picture taken in a lift. Suppose 0 is a ground floor. The positive number will represent the floors above the ground floor, whereas the negative numbers will represent the floors below the ground level, that is the basement. This is an example where we use fractions. As you can see, the first measuring cup is a whole number. Then we have half, 1/3, 1/4, and 1/8. We usually use these measuring cups in the kitchen to measure ingredients. So let's start with natural numbers. Natural numbers are used for counting. They are also known as counting numbers. The set of natural numbers is denoted by the letter n, where n is equal to 1, 2, 3, 4, 5, 6, and so on. So the set of natural numbers is an infinite set. Students, you remember the meaning of an infinite set? You learned it in grade 7. Well, an infinite set is a set containing an infinite number of elements. That is, we cannot count the number of elements because there are so many. So natural numbers starts from 1 and goes on and on and on. Let's talk about whole numbers. 0 is not considered as a natural number. We have just seen that natural number starts from 1. But 0 together with the natural numbers form the set of whole numbers. The set of whole numbers is given as 0, 1, 2, 3, 4, 5, etc. Here also, you're going to notice that the set of whole numbers is an infinite set. Before going further in this chapter, let's do a recap on integers, whatever you have learned in grade 7. The set of integers consists of positive whole numbers, 0, and negative whole numbers. We use the letter Z to denote the set of integers. So the set of integers contains negative numbers, 0, and positive whole numbers. As you can see in this set, the numbers written in brown, they are, can you guess? Yes, they are the set of natural numbers which we have just talked about. So the set of natural numbers is a subset of the set of integers. We can write it in set notation, as you can see on the screen here. N is a subset of Z. Now let's talk about positive integers. The set of positive whole numbers are also known as positive integers. The set of positive integers is denoted by the letter Z with superscript plus. That is, we write a plus to know that we are just talking about positive integers. So z is equal to 1, 2, 3, 4, etc. So it is same as the set of natural numbers. So the set of positive integers is the set of natural numbers. Let's talk about negative integers now. The set of negative whole numbers are also known as negative integers. We use the letter z with superscript minus, where z superscript minus equal to, we have minus 1, minus 2, minus 3. We start from the right to the left. That is, we go on and on to the left hand side. That is, we take smaller and smaller numbers. If you're talking about integers, we must always remember that integers can be represented on number lines. Well, 0 is known as the neutral integer. The 0 is neither positive nor negative. Here it is, the neutral integer. On the right hand side we have 1, 2, 3, 4, and so on. These are the positive integers. On the left hand side we have minus 1, minus 2, minus 3, minus 4, and so on. These are negative integers. We are doing a recapitulation on number lines because in this chapter we are going to place other types of numbers on this number line. We are going now to talk about rational numbers. Rational numbers are numbers which can be expressed in the form p over q, where p and q are integers, but q is not equal to 0. In set notation, we write the set of rational numbers, which is denoted by the letter q. So q is equal to all the numbers which can be written as p over q, where p and q are integers and q is not equal to 0. Again, this is an infinite set. Let's have some examples of rational numbers. Half is written p over q. 2/3, minus 7 over 5. 1 1/4, 2.5, 6, minus 9, minus 0.03. Now you will think that how can 1 1/4 be a rational number? We have just said rational numbers are numbers that can be written as p over q. Same applies for 2.5. You're going to say it's not written as p over q. Let's see how and why they are called rational numbers. First, let's start with minus 7 over 5. You must remember that this negative sign can be written in the numerator as well as in the denominator. We do not write the negative sign in both numerator and denominator because it will be as negative divided by negative, which is positive. So if we have a negative sign in front of a fraction, we can leave it in front of the fraction, in the middle, or you write the negative sign with the numerator or the denominator. We were talking about 1 1/4. Why we call this a rational number? Because 1 1/4 can be written as 5 over 4. You learned about it in grade 7, how to write a mixed number as an improper fraction. 2 decimal 5. What is 2 decimal 5? 2 decimal 5 is same as 2 1/2, and 2 1/2 is same as 5 over 2. 6. Is it p over q? Yes, because 6 is equal to 6 over 1. Now we can have equivalent fractions. 6 over 1 is same as 12 over 2. Minus 9. Again, this is a rational number because we can write it as minus 9 over 1. We can have an equivalent fraction, which is 27 over minus 3. Remember that. Since we have a negative sign in front of 9, we cannot write that negative sign in both the numerator and denominator. We must either write the negative sign in the numerator or in the denominator. Minus 0.03 is same as 3 over 100. So P over Q, hence it is a rational number. Okay, the negative sign can be written either in the numerator or the denominator. So students, what can you observe from all these numbers? You have seen that in all these numbers, we have written them as P over Q, that is, the numerator and the denominator are integers. Now, let's place these numbers on a number line. That is, these rational numbers on a number line. Let's start with 1.5. 1.5 is same as 1.5. You know that 1.5 is a number that lies between 1 and 2. Since we have a denominator 2, we are going to have two sub-intervals between 1 and 2. That is, first and the second sub-interval. Now, the numerator here is 1. So you're going to tick the mark to the right. Here it is, 1.5. So we have placed 1.5 on a number line. Similarly, for 3 3/4, 3 3/4 is a number which lies between 3 and 4. The denominator here is 4, so we are going to have 4 sub-intervals between 3 and 4. 1, 2, 3, and 4. Since the numerator is 3, you're going to tick the third mark to the right. First, second, third. Here it is, 3 3/4. Minus 7 over 3. Minus 7 over 3 is same as minus 2 1/3. We're going to repeat the same procedures. We have 3 sub-intervals, but since we are working with negative number, we are going to work to the left. 3 sub-intervals. Now, the numerator is 1, so we tick 1 mark to the left. Here it is, minus 7 over 3, or minus 2 1/3. Now, we are going to find a rational number. Remember, rational numbers are numbers that can be written as P over Q, where P and Q are integers. We're going to find a rational number between 1 over 6 and 5 over 6. Since the denominators here are 6, we are going to have 6 sub-intervals between 0 and 1, because both 1 over 6 and 5 over 6 are numbers or fractions found between 0 and 1. Here it is. Between 0 and 1, we have 6 sub-intervals. This is 1 over 6, and this is 5 over 6. We wanted to find rational numbers between these two, so they are 2 over 6, 3 over 6, and 4 over 6. Now, this 2 over 6 can be written in its lowest term. 2 over 6 is 1/3. 3 over 6 is how much? Yes, half. 4 over 6 is 2/3. So, possible answers for rational numbers between 1 over 6 and 5 over 6 are 1/3, half, and 2/3. Now, let's have a look at this example. We are going to find a rational number exactly halfway between half and 5 over 6. We are not going to find all rational numbers or some rational numbers between them. We're going to find only one which is exactly halfway between half and 5 over 6. Now look at the denominators here, 2 and 6. To be able to find a rational number exactly halfway, first we need to write the two fractions with the same denominator. So first, let's find the LCM of 2 and 6, which were the denominators. The LCM is 6. So half is written as 3 over 6. The other one was already over 6. The denominator was 6, 5 over 6. So we place them here. Can you guess the rational number which is exactly halfway? What is it? Yes, 4 over 6. So So 4 over 6, you know that we can write it in its lowest term. The answer for this question, the rational number which is exactly halfway between half and 5 over 6, is 2/3. Now let's look at this exercise. The first one, on separate number lines, show the approximate position of the following rational numbers. You're going to draw a number line, then you're going to place these rational numbers. Remember that 2^2 can be written as a fraction that is p over q to be a rational number. Here you're going to find rational numbers between 1 and 2/3. There might be more than one, but you're going to write only one. Here you're going to find a rational number which is exactly halfway between these two given rational numbers. So students, in this video you learned about natural numbers, whole numbers, and rational numbers. You also learned how to differentiate between them. We have placed rational numbers on number lines, and we have also found rational numbers between two given numbers. If you want to have some more information on this topic, you can log on to the following website. So students, this program ends here. Remember that this video is the first part of the chapter Real Numbers. See you soon for the second part. Till then, goodbye.